everyone, myself P. Rashika, working as assistant professor in SNS College of Pharmacy and Health Sciences in Department of Pharmaceutics. Today we are going to see the topic of surface and interfacial phenomena. When phases exist together, the boundary between two of them is known as an interface. Surface is the term used to describe either a gas solid or gas liquid interface. The properties of the molecules forming the interface are often sufficiently different from those in the bulk of each phases that they are referred to as forming an interfacial phase. If a liquid and its vapors exist together in the same container, the liquid takes the bottom part of the container. The remainder of the container is filled up by the liquid vapor, which is with any gas has a tendency to take all available spaces. Molecules in both the liquid and gas are in constant motion and can move from the liquid into the vapor and back from the vapor to the liquid. Liquid interface. Different types of interface can exist depending on whether the two adjacent phases are either in the solid, liquid or gaseous state. For convenience, these various combinations are divided into two groups such as liquid interface and solid interface. Solid interface will deal with the system containing solid gas and solid liquid interface. In the liquid state, the cohesive forces between adjacent molecules are well developed. Molecules in the bulk liquid are surrounded in all directions by other molecules for which they have an equal attraction. But molecules at the surface, that is at the liquid or air interface, can only develop attractive cohesive force with the liquid molecules that are situated below and adjacent to them. Their various interfaces exist. Classification of interface, phase and types and example of interface. In gas case phases, there is a no interface possible. Gas and liquid, there is a liquid interface. The examples are body of water exposed to atmosphere. In gas liquid phase, there is a solid surface interfaces are present, and the example of interfaces are tabletop. In liquid there is a types of liquid interface, that is examples are emulsion. In liquid solid interface there is a suspension of example. In solid interface there is a powder particles are the example. The word surface is used to designate the limit between a condensed phase and a gas phase, whereas the term interface is used for the boundary between two condensed phases. Surface tension. The tension that exists between solid gas phase and liquid gas phase is known as surface tension. The origin of surface tension in a liquid is the cohesive force of attraction between the molecules that make up the liquid. In the absence of other forces, this mutual force of attraction of the molecules causes the liquid to collisions in accordance with the Laplace law. Laplace law. In the bulk of liquid, each molecule is pulled equally in all directions by neighboring liquid molecule, resulting in a net force of zero. This force is the surface tension, defined as the magnitude of force acting perpendicular to a unit length of line at the surface. According to definition, the surface tension is expressed as a gamma equal to F by L. Gamma represents surface tension. F is the perpendicular force perpendicular to the length. Surface tension is represented by different symbol like gamma or sigma. Unit surface tension and interfacial tension are force in surface tension. It is, represents dies per centimeter. In a SI system is N by M. In interfacial tension is measured in dynes per centimeter. In SI system is N by M. Surface free energy. Each molecule of the liquid has a tendency to move inside the liquid from the surface. Therefore, the liquid takes place from the minimal free forces and with the minimal surface energy. Is it describes the excess energy that surface has compared to the bulk of the material. The energy is proportional to the size of the free surface is called as surface free energy. So measurement of surface and interfacial tension are the capillary rise method, the dew knob ring method, drop count method, drop count or drop weight method, Wilfley plate method. Now we are going to see the topic of capillary rise method. When a capillary tube is placed in a liquid contained in beaker, the liquid generally rise up and tube a certain distance. That is a schematic diagram of capillary rise water. That is a beaker that is placed in, and then this is a beaker. So it will be placed in the beaker. You placed the liquid contained beaker, or you have to place capillary tube in the beaker. This is a capillary rise method, and because of the force of adsuction between the liquid molecules and capillary wall is greater than the cohesion between the liquid molecule, the liquid is said to be capillary wall spreading over it and rising in the tube. By measuring the rise in capillary, it is possible to determine the surface tension of the liquid. It is not possible, however, to obtain interfacial tension using a capillary rise method. If the contact angle of liquid is not zero, exit the vertical component of F, which opposes the weight of the column. Therefore, F cos theta, and therefore surface tension is gamma equal to RdGH divided by 2 cos theta. If the contact angle of liquid is 0, the surface tension is given by gamma equal to 1 by 2 RdGH. R is the radius of capillary tube, D is the density of the liquid, H is the height of the liquid rise, G is the acceleration due to gravity, gamma is the surface tension of the liquid. The Dewey ring method. Dewey tensionometer is widely used for measuring the surface and interfacial tension. The principle of the instrument depends on the fact the force is necessary to detach the platinum iridium ring immersed at the surface or interface is proportional to the surface or interfacial tension. The force required to detach the ring in this manner is provided by the torsion wire and recorded in dienes on a calibrated dial. It is the schematic diagram of Dewey ring method. R equal to dial reading in gamma equal to dial reading in dienes divided by 2 into ring substance in correction factor. In effect, the instrument measure the weight of liquid pulled out to the plane of the interface immediately before the ring becomes detached. A correction factor is necessary in equation 7 because the simple theory does not have in account certain variables such as the radius of ring, radius of wire used to form the ring, the volume of liquid arised out the surface. Errors as large as 25% may occur in the correction factor is not calculated and applied. Thank you.